In this video, I'm going to show you how to derive the famous quadratic formula. So you've been giving questions like this one on the right throughout high school, where you were asked to find the root or the x. First you do that by identifying the a term, the b term, and the c term, and you just plug each one of them into this formula on the left side, and it will just give you the two solution for this equation right here. So you were given this formula, right? But like there was never a why or how. So you might sometimes wonder, like, how do people get these like formulas, and how did they obtain them? How did they know that it was true in the first place, right? So that's what I'm going to show you today. So we start out by writing what we want to solve, which is ax squared plus bx plus c equal to 0. So this is in the, these two are kind of like identical, but in this case that we have some actual number instead of just a and b and c, but they're kind of like in the same form. So we want to solve this here. So how do we do that? We do that by first completing the square. So you learned in grade 11 math that the first step to complete a square is to divide everything in it by a. So let's do that. So a squared divided by a plus bx over a plus c over a. You notice that in the first term we have 2a, so we can just cancel that out. Oh, forgot to add a 0. And then that will make it become x squared plus bx over a plus c over a equal to 0. And that was the first step for completing the square. And you also learned that in the second step to complete the square is that we have to identify the b, divide a b by 2, then square it, right? So in this case, our b is, well, let's use a red pen right here. Our b here is b over a. So we want to divide by that by 2, which should give us b over a divided by 2, which is b over 2a, right? Then we want to square that. So b over 2a squared. Then we want to add this to our original equation, add and subtract it at the same time, of course, to make things balanced. So that will make this become x squared, plus bx over a plus b over 2a squared minus b over 2a squared plus c over a equal to 0, right? And if you notice, the first return here, I'm going to use a green pen. So the first return here becomes x plus b over 2a squared. So the first return becomes this. Then we still have b over 2a squared plus c over a equal to 0 here, right? So now what we want to do is that we want to move these two terms to the right side. So if you have a negative term, you move the negative term from the left to the right, it becomes positive. And if you have a positive term on the left, if you want to move that to the right, it becomes negative. So in this case, this will becomes, let's write x plus b over 2a squared. You want to move these two to the right side. So we have a negative b over 2a, so that will becomes positive b over 2a squared. And then you have a positive c over a, and that will become a negative c over a. So let's further simplify the terms on the right. So we have b over 2a squared, right? So what would this become? Well, this will become, if you square the top, b squared is b squared. And if you want to square 2 squared is 4. And if you, let's write that 4 better. And you want to square the a, which then it becomes a squared, right? So let's rewrite our equation in a more complete form. This will become x plus b over 2a squared equal to b squared over 4a squared minus c over a, right? So this will be our complete one for now. So now we need to consider, actually before we do that, there's one more step we can do, which is to further simplify this. Let's actually move this whole thing on the right to here. So if we have b squared over 4a squared minus c over a, so how will you further simplify this? Or the other question is, how will you minus this? We learned that in grade 8 or grade 9 mathematics that if we want to minus a fraction like this, we need to make the denominator the same. So we want to time, so we want to make c over a, the bottom of which is the a, the same as 4a squared. So how do we do that? We multiply it by 4a. And then if we want to multiply 4a on the bottom, we have to multiply that on the top as well. So this will become, this stays the same. So 4a times a and 4a times c, right? Because we want to multiply 4a to make the denominator the denominator the same. But if we multiply 4a on the bottom, we have to do that on the top to make everything balanced and the same, right? So then this will simplify to b squared over 4a squared minus, let's write that 2 better, and then 4ac, which is then 4a squared, because a times a is just a squared, right? So now we have the same denominator. We can then make this becomes b squared minus 4ac over 4a squared, right? So let's go back to our ordinary equation and then make this. So this will now becomes b over 2a squared equals to b squared minus 4ac over 4a squared. And then right now, this will be our complete form for now. So now we need to look at 3 different cases to consider, okay? So let's move this to the bottom by doing this. That was kind of bad. That kind of removed the 2 for some reason. Let's look at this. So we need to look at 3 different cases. So the first case, so let's write that. First case is where b squared minus 4ac is smaller than 0, right? So what does this mean? If b squared minus 4ac is less than 0, then this whole term on the right, which is, oh god, b squared minus 4ac over 4a squared must also be smaller than 0. Because if the top term is smaller than 0, it means that it's a negative number, right? So if we have a negative number on the top, let's say the top is -5, and then the bottom, let's say a is like -4. And then if -4 squared, so if we square that negative a on the bottom, it becomes a positive number. So regardless of what a is, the bottom will always be a positive number. And then we know that if we have a negative number on the top and a positive number on the bottom, we're guaranteed to get a negative number overall. So we know that b squared minus 4ac over 4a squared is guaranteed to be smaller than 0. And then looking back our original formula, which is this, right? If the right side is smaller than 0, the left, let's look at the left side. So left side we have x plus b over a. So this is, if we look at this, this has to be positive, because no matter what term you put in, like no matter what number you substitute for x, a, or b, whether a negative or positive, this will always be bigger than 0. So this kind of contradicts, because on our right side, it's smaller than, it must be smaller than 0. But on our left side, it must be bigger or equal to 0. So it will kind of contradict. So therefore, in this case, there is no solution. Is no solution. So this is the first case that we need to look at. And then we have the second case where b squared minus 4ac is equal to 0, right? So if b squared minus 4ac is equal to 0, then we'll get 0 over 4a squared, right? Which will then be equal to 0. And then if we know that x plus b over 2a squared is equal to 0, how are we going to solve this? Well, we take the square root of 0, which is 0, right? So x plus b over 2a equals the square root of 0, which is 0. Then this becomes x plus b over 2a equal to 0. Then what is x? X just becomes negative b over 2a. So in this case of where b squared minus 4ac is equal to 0, we only have one solution. And then you can obtain that solution by using negative b over 2a. So this is our second case. Our third case, well, you can kind of guess it, is where things get interesting, is that b squared minus 4ac is bigger than 0. Is bigger, it's not bigger than equal to. It's just bigger than 0. So if we can just solve this right here. So let's look at our original equation. So x plus b over 2a squared is equal to b squared minus 4ac over 4a squared, right? So how do we solve this? Well, we solve this by getting rid of this square first. And to do that, we need to square the whole right side because we want to get rid of the square on the left side. So this will becomes x plus b over 2a square root of b squared minus 4ac over 4a squared. So we got rid of the square on the left side by square rooting the right side, right? And then what is the next step? Well, the next step is to move, because we want to solve for x. Well, I forgot one thing that's important that you guys never need to forget, is that if we have a square, there's always got to be a plus and minus in front of it, because the solution might be plus or it might be minus, right? So I forgot that. And you guys need to remember that forever, because I actually, in one of my college class, I actually got the mark cost off for doing this, right? And let's keep on our, so we want to solve for x. And how do we isolate x? Well, we move the b over 2a from the left side to the right side. And meanwhile doing that, it will become negative, right? Because if we're moving a positive term from the left side to the right side, it becomes negative. So this whole thing becomes x equals to negative b over 2a plus minus, remember, b squared minus 4ac over 4a squared. And this ultimately becomes negative b plus minus b squared minus 4ac over 2a, which there you have your quadratic formula right here. And then, so actually I forgot, x equals to this. Sorry, there, we just obtained it. And then this will give us two solutions. Like if we go back to original one right here, if we solve this will give us two solutions, and one is positive and one is negative. So in terms of the quadratic formula, there could always be three possible scenarios, which is the first case where there is no solution if b squared minus 4ac is smaller than 0, or the second case where there is only one solution, and you get that solution by using this formula right here, or the third case where there are two different solutions and you use the formula right here. So there will be three different cases for a quadratic like a quadratic term, right? Okay, and that will be the derivation of quadratic formula. And I think that's pretty important that you guys try deriving this by yourself, because you will then understand how this formula is actually obtained. It's like in mathematics, you shouldn't just use something because somebody tell you that is right. Maybe like using, well, I don't want to derive it, that's kind of complicated and hard and all that stuff. But only when you derive it yourself, you will only know it that it is true, and look at how the way that derive it, and then you can use this to maybe that deriving method, or to gain like a mathematical intuition by looking at this these derivation. But I think so. Ultimately, I think knowing how to derive formulas like this are important, right? So that will be the end of it for this video, and I'll make it more on the upcoming week. But okay, if you like this video, please subscribe, and I guess bye.